سلام، خوش اومدید به شب 84 روم مجموعه در این شبها. در این برنامه و در این قسمت من میزبان دکتر سارا سیگر خواهم بود، یکی از شناخته شده ترین چهره های عرصه مطالعات سیارات فراخورشیدی، به خصوص جو فراخورشیدی ها و یکی از پیشگامان این رشته. دکتر سیگر در شهر تورنتو در کانادا به دنیا اومدش و تحصیلات مقدماتی خودش رو در اونجا سپری کرد. اونطوری که در خاطراتشون می‌نویسن، یکی از نخستین خاطرات ثبت شده در ذهنشون یک شب و برنامه رصد عمومی هست که از پشت تلسکوپ میتونن ماه رو ببینن و خب مثل خیلی از ماها این براشون یکی از نقاط عطف میشه که شاید تاثیرگذار باشه که در واقع مسیر زندگیشو در حوزه ستاره شناسی ادامه بده. او در دانشگاه تورنتو رشته ریاضیات و فیزیک رو میخونه و بعد در دانشگاه هاروارد ستاره شناسی رو. در نیمه دهه 90 زمانی که کشف فراخورشیدی ها آغاز میشن، او تمرکز اصلی خودش رو در حوزه فراخورشیدی ها میذاره. به یکی از نخستین کسانی بدل میشه که پایان نامه و تحقیقات اصلی خودش رو جو فراخورشیدی ها گذاشته بود. پروژه و سوژه‌ای که اون زمان حتی با بدبینی در بین همکارانش روبرو میشه که این خیلی سوژه عجیب غریب و دور از ذهنیه، اما اون این کار رو ادامه میده و الان که شناخته شده ترین چهره‌هایی است که در زمینه فراخورشیدی ها و همینطور به طور خاص جو فراخورشیدی ها ما فعالیت میکنه و مرزهای شناخت ما رو داره تغییر میده. سارا سیگر الان در دانشگاه MIT به تحقیق و تدریس مشغوله. جوایز بسیاری رو برده، از جمله جایزه کتاب هاروارد، جایزه هلن وارنر. او همینطور برنده فلوشیپ معروف مکارتور هستش که یکی از شناخته شده ترین و مهمترین در واقع فلوشیپ های حوزه علم هستش و همینطور به واسطه خدماتش به علم در کانادا به سمت افتخاری آفیسر در اردر کانادا منصوب شده. در سال 2024 بنیاد کابلی به واسطه تلاش‌های او در زمینه افزایش درک ما از فراخورشیدی ها جایزه ویژه خودش رو در بخش ستاره شناسی به سارا سیگر تقدیم کردش. در طول سالهای گذشته، شاید بیش از 10-15 سال گذشته، شاید هم بیشتر، من این شانس رو داشتم که بارها به شکل مکتوب در واقع با دکتر سیگر مشورت کنم. مصاحبه هایی از ما در مجله نجوم به چاپ رسیده. امروز خیلی خوشحالم که میتونیم به شکل ویدیویی با هم صحبت بکنیم و از شما دعوت میکنم که این گفتگو رو ببینید.
So thank you very much, Professor Seager, for joining us.
خیلی ممنون خانم دکتر سیگر که دعوت من رو پذیرفتین. پیش از هر چیزی تبریک میگم بهتون دریافت جایزه کابلی 2024 رشته اختر فیزیک رو. ما حدود 3 دهه پیش برای نخستین بار یک سیاره فراخورشیدی رو موفق شدیم نشانه‌هاش رو کشف کنیم. حالا 3 دهه بعد و بیش از 5700 سیاره فراخورشیدی تایید شده، تقریبا دید ما رو نسبت به کیهان عوض کرده. من میخوام با این شروع بکنم که با توجه که شما یکی از نخستین کسانی هم بودید که روی این حوزه کار می‌کردید، در این 3 دهه چه تغییراتی در دید ما نسبت به دنیا ایجاد شده، نسبت به تولد، تحول و تکامل منظومه‌های سیاره‌ای که در اطراف ستاره ها وجود دارند؟
In general, this field of exoplanets expanded our view of the universe.
Well, I'd say the primary thing exoplanets did for us was, first of all, it demonstrated that our solar system is not alone. That we're not the only planets out there. And of course, people thought about this for thousands of years, but it's amazing we finally had the technology to do that. The second thing is we found that our solar system is not the typical planetary system. Remember before, I don't know about when you were a child, but when I was a child, it was just assumed that all planetary systems once found would be like our own, with Mercury, Venus, Mars close to the star, Jupiter, Saturn far from the star. And that's not the case. As you know, the first planets found around sun-like stars were giant planets very close to the star, several times closer to their star than Mercury is to our sun. Now we find planets in all kinds of masses, sizes, and orbits. And the most common planet out there appears to be one that's 2 to 3 times the size of Earth with no solar system counterpart. We call them sub-Neptunes. We have no idea how they formed or even what they're made of, really.
So actually, based on what
خب آیا بر مبنای این اطلاعاتی که به دست آوردیم ما مدل جدیدی برای تحول منظومه شمسی داریم؟ چون همونطور که گفتیم قبلا فکر می‌کردیم که مثلا یه ستاره تازه متولد شده در مرحله تاسوری خودش انبوهی از طوفان‌های ذرات قوی رو یا انرژی قوی رو از خودش ساطع می‌کنه، گازهای سبک رو به دوردست منظومه میبره و بخش سنگین‌تر در نزدیکی باقی مونه. الان به نظر میاد بر مبنای اون چیزی که یافتیم این گونه نیستش. آیا مدل جدیدی داریم که این رو توضیح بده؟
Well, as you know, models, theories, and science, they're continually being revised.
Yeah.
I'd say planet formation is continually being revised based on evidence, for sure, but many of the original ideas still hold. Like giant planets start by accreting planetesimals, and then they get massive enough. Some of them open a gap in the disk, and gas flows across it, and they are like a cosmic vacuum cleaner and suck up all the gas in their gravitational sphere. So I'd say it's definitely been revised, but as far as I understand, these sub-Neptune sized exoplanets, we still don't have an agreed upon way that, as far as I know. So definitely a challenge.
Yeah.
قبل از اینکه ادامه بدیم من این سوالو حتما ازتون بپرسم که از بین این همه سیستم های مختلف به سیاره‌ای که پیدا کردیم، سیارات مختلف، حتی سیارات سرگردان، کدومشون بیشتر از همه شما رو شگفت زده کرده و در واقع چیزی بوده که انتظارش رو نداشتیم هیچ وقت پیدا بکنیم و شگفت زده‌مون کرده؟
So many of them. But I'm going to have to land on these sub-Neptune sized exoplanets as most mysterious, because imagine that. So common. We don't have one in our solar system. And why they're so mysterious is they're very, very average density. Do we have time for a mini thought experiment?
Sure.
Okay. Let's take the planetary materials to be in three categories. Let's take iron and some rock, water, and hydrogen. Let's just take three very different density materials. And let's imagine I give you a box right now. I hand you a box and I say, your job is to guess what is in this box out of those materials. So let's say I give you a box and it's so heavy, it just falls to the ground. What would your guess be? Iron?
Yep.
Iron with a bit of rock, water, or hydrogen?
Probably the first guess is iron, right?
Iron, if it's super heavy and it just, wow, because the density is so high.
Yeah.
Now let's imagine I give you a box and it starts floating up. It starts floating away like one of the balloons made of helium. What would your guess be? Between
hydrogen.
Hydrogen, right. Now, what if I give you a box and it's just like medium? It's kind of average. It's not really falling to the ground. It's certainly not floating away. Then what?
There's probably water.
Well, it could be water, but
Or
what if
something.
it's a mixture? What if it's a mixture of hydrogen and the iron rock?
Yeah.
What if it's a mixture of all three? So these sub-Neptune sized planets, they're what I described. They're this very average density, and a lot of different options could create that average density.
Oh, yeah.
Yeah.
So they could contain of the heavy element and light element, but in average, the density is actually
right. And you know what? We love to believe they're water worlds, that they're 50% or more water by mass, like a scaled up version of one of Jupiter's icy moons.
Yeah.
But these planets were not only the most unexpected, but also the most mysterious, because they're not easy for us to figure out what they're made of on the inside. And right now, people are trying to connect atmosphere measurements to sort through the options.
And
به جوهای سیارات فراخورشیدی اشاره کردید، من برمیگردم به این، اما قبل از اون چیزی که می‌خواستم بپرسم اشاره بود که به سیارات میزبان آب کردید، به اینکه ما دوست داریم سیارات آب داشته باشن. شاید یه دلیلش این باشه که علاقه‌مند پیدا کردن حیات در بیرون زمین هستیم و حیات حداقل به شکلی که ما میشناسیم وابسته به آب هستش. میخواستم ازتون بپرسم که با توجه به تعریف سنتی که ما از منطقه زیست‌پذیر یا سیاره زیست‌پذیر داریم، سیاره شبیه زمین، میزبان آب، درون فاصله‌ای که به نام کمربند زیست در اطراف ستاره میشناسیم، اولا چقدر ما فاصله داریم با پیدا کردن اون چیزی که زمین شماره 2 یا زمین 2.0 میشناسیمش، و از اون مهمتر آیا با توجه به چیزهایی که یاد گرفتیم در رابطه با برای مثال اقمار مشتری که ممکنه میزبان آب باشن، اساسا راهبرد جستجوی سیارات زمین مانند میزبان حیات در کمربند سنتی حیات روش درستیه، یا ما باید بریم به سراغ برای مثال اقمار سیارات فراخورشیدی و موارد دیگه ای مثل اون؟
moons of the exoplanets as well?
Well, there's a lot. These are really hard questions. You know, an Earth 2.0, if we want an Earth 2.0 around a sun-like star, that is a ways off. But if you're happy to consider something, maybe it's not quite Earth 2.0, but like Earth around, and well, I mean, it depends how you want to define Earth 2.0.
Exactly.
خب فکر می‌کنم که مسئله اصلی همینه برای عمده مخاطبان عام، حالا نه افراد متخصص. زمین شماره 2 سیاره‌ای سنگی مثل زمین دارای منابع آبه که یا در منطقه زیست‌پذیری، کمربند زیست‌پذیری ستاره مادرش که حالا اگه نه دقیقاً مثل خورشید ولی قابل مقایسه باشه قرار داره و امکان شکل‌گیری حیات یا حداقل شکل‌گیری عناصر و بلوک‌های سازنده حیات در اون وجود داشته باشه.
Well, we're working to answer that question right now. If we're really, really lucky, we might have one already. We just don't have enough observations to know if it's got oceans and continents. There are the world's favorite planets, it's fair to say, are the TRAPPIST planets. 7 planets transiting a very, very small red dwarf star. But the environments are not anything like here on Earth.
Yes.
These planets are tidally locked due to energy, a special energy state. And what it ultimately means is that the star is in the same place in the sky at all times.
Yes.
There's no day or night.
They're locked, actually.
They're locked. They're rotating one time for every time they orbit, and they show the same face to the star at all times, just like the moon shows the same face to Earth. Also, on these stars, they're receiving so much radiation from the host star. The host star is very magnetically active, and it has spots and flares and coronal mass ejections likely, and a lot of other things. So that is complicated, and it's making us wonder if these planets were able to maintain an atmosphere or if they've lost the atmosphere due to the star being very active, especially during the first few hundred million years. The star was spewing out a lot of energy. But yeah, we might have those already. So how long is it before we decide that? It could be a few years, a few to several, where we work through all of our current problems.
And as you mentioned,
همونطوری که اشاره کردید در واقع پیدا کردن این نشانه‌های الزاما به معنای پیدا کردن حیات نیستش با توجه به پیچیدگی که داره. این منو برمیگردونه به سوال دومی که داشتم و اونم اینه که آیا ما باید دوباره معیارهای زیست‌پذیری و منطقه زیست‌پذیری برای سیاره‌ها رو عوض بکنیم؟ انبوهی از تحقیقات وجود داره که برای مثال اشاره میکنه به اقمار سیارات فراخورشیدی یا سیارات فراخورشیدی که بیرون کمربند سنتی حیات قرار دارن. آیا ما باید دوباره اینو بازنگری کنیم؟
Well, interestingly, we're very limited observationally. So far, it's at the very edge of our ability to even try to establish whether or not a planet is habitable. And because the moon is so much smaller than a planet, barely study the planet, the moons are out of reach for now. So moon might be better, but we haven't found any exoplanet moons that people agree on are there. Right now, they'd be too small for us to follow up looking at their atmospheres. So even if moons are good, they're observationally they're out of reach observationally.
So one of the challenges probably is
یکی از مشکلاتی که ما در این جستجو داریم مسئله فنی و تکنولوژیک هست و این در واقع موضوعی که میخوام ازتون سوال کنم. زمانی که تلسکوپ فضایی جیمز وب به فضا پرتاب شد، یکی از اهداف چهارگانه اصلی اون کمک به پیدا کردن فراخورشیدی ها و افزایش درک ما از این سیارات بودش، اینکه توان بیشتری رو برای شناسایی اونها داره. سوال من این هستش که آیا بر مبنای داده‌هایی که تا الان جیمز وب فرستاده آیا تونسته این اهداف رو تحقق ببخشه؟ آیا انتظارات رو برآورده کرده؟ حالا بعدش من در رابطه با 2 مأموریت دیگه که شما هم به شدت درش درگیر هستین ازتون خواهم پرسید.
Well, the James Webb has given us an amazing new era in exoplanet studies by having just fantastically high precision data to study atmospheres of exoplanets, and that has been incredible. Can the James Webb Space Telescope fulfill its promise for exoplanets? We're working on a major problem right now, myself and hundreds of others, And that is, these M-dwarf stars that host the planets we can study, they're very magnetically active, and their spots make the star contaminate our observations, actually.
It's something like the sunspots in our solar system, but very larger and more...
Right. The sunspots are pretty harmless.
Yeah.
But star spots on these M-dwarf stars, there are more of them, and they might be larger, and they're contaminating our observations right now. So there's a lot of people in the community trying to figure out how to damp down this contamination, how to remove it, and only then will we be able to fulfill the promise of the web. So stay tuned.
Sure, of course. And
در مورد نسل بعدی تلسکوپ‌های فضایی چطور؟ برای مثلا شما الان در حال آماده کردن تلسکوپ فضایی نانسی گریس رومن هستید که بخشی از مأموریت اون هم در واقع بررسی سیارات فراخورشیدی هستش. چقدر خوشبین هستید به دستاوردهایی که اون میتونه داشته باشه برای کمک به درک ما از فراخورشیدی‌ها؟
Well, Nancy Grace Roman telescope will be searching for planets by microlensing. And they will do a great job in terms of the census of exoplanets. Right now, because every planet finding techniques has major biases, we are unable to tell you how common our solar system actually is out there. Because, Jupiter is very hard to find, and Earth is very hard to find as well. So what the microlensing will do is it'll survey stars, huge numbers of stars at the same time, looking for microlensing events. And they're going to be microlensing is very sensitive to planets between 1 and 4 times the Earth-Sun distance, 1 to 4 astronomical units. So we're really looking forward to microlensing. In addition to microlensing, the Roman telescope has a kind of tech demo coronagraph, light blocking device inside the telescope that's going to block out starlight so we can see planets directly. And that is extremely important for our future, the future ways that NASA wants to search for Earth 2.0.
Yes.
من خاطرم از چند سال پیش در واقع یکی از سخنرانی‌های شما در کنفرانس تد رو ترجمه می‌کردم به فارسی و اونجا اشاره کردید به فناوری استارشید یا ستاره پوش و حتی در واقع خاطراتتون هم در واقع به اون اشاره کردید. قرار بر این بودش که در واقع این بخشی از پروژه و مأموریت هابکس باشه. میتونی به ما بگی که وضعیتش الان چطوره؟
Right, well, let me update you on that, but just hold on a second.
Sure, of course. Oh. Wow.
Do you want to describe what you're looking at so it gets on me?
Sure, this is amazing. This is I believe
این فوق‌العاده است. این در واقع ساختار ستاره پوش هستش که نور ستاره ها رو مهار میکنه و اجازه میده که نور کمسوتر و ضعیفتر سیارات احتمالی که اطرافمون هست به ما برسه.
Let me turn this so you can see
Thank you.
Do you know what that is?
Wow. Yes.
So we just looked at a 1% scale model of Starshade.
This is 1%.
The little one I showed you is 1%.
Yes.
And that is a 1% scale model of Starshade, which would be a giant specially shaped screen with its own spacecraft that flies in outer space, and Formation flies with a space telescope. So Starshade will block out the starlight before any of the light enters, so that only planet light will enter the telescope. And Starshade was invented in the 1960s, and each decade it kind of got shelved and then revived and then shelved and revived. And finally, we were able to bring Starshade to something that can actually be built. And what you see on my wall here is a full-scale pedal.
Yeah. Oh.
Yeah.
This is one of the pedals, actually.
One of the pedals. So that corresponds to one of these. And this 1% scale Starshade was actually used in the desert in Nevada in the southwest United States. And they had a few kilometers where at one end there was an LED that was a fake star and planet, a simulated star and planet. The Starshade was somewhere in the middle. And at the other end, they had a camera, like a telescope, to collect the light. And they demonstrated it works to about 10 to the minus 8. But it has to, in the desert. But the desert has like air and turbulence.
Exactly, the turbulence and
It's not a perfect case, but a smaller scaled version of Starshade has been tested in an 80-meter long tunnel at Princeton and has shown to work basically the proper scale. So Starshade gets us to where we have to go, to an incredible blocking out starlight, to one part blocking out starlight. We literally have to block out 10 billion photons of the star so that the 1 billion photon from the planet reaches the telescope, because our Earth and sun, in reflected light, our Earth is 10 billion times fainter than our sun.
Yes.
I mean, I like to ask people, did you ever build a deck or build something at home? Sure. Let's imagine you're building a deck on the back of your house, or you have to get a carpet for your balcony. Mm-hmm. And let's imagine it's like 10 feet across.
Mm-hmm.
Are you going to measure something, a carpet or some wood that's 10.0 feet? Or would you measure 10.0000 feet? Well, in this case, we have to block out light to 10 decimal places.
Yes.
And so we have to build something that's like almost impossible to build. And we have shown that Starshade is mature technologically. It is, it works like in the scale model, it works in the computer. And so Starshade is my favorite way to find another Earth. Yeah. At the moment, NASA has plans. We've evolved beyond HabEx and LUVOIR, but NASA has decided to build something called Habitable Worlds Observatory. And this will be one of NASA's next great observatories. But at the moment, it doesn't include Starshade. Right now, Habitable Worlds Observatory includes a coronagraph, like a light blocking device on the inside of the telescope. And we're trying to make Starshade keep it out there so that it could be like a second generation instrument, because Starshade is incredibly powerful in how it blocks out the starlight, and it makes a very, very efficient planet characterizer.
و زمانی که ما اینو توسعه بدیم و به فضا پرتاب کنیم، این ستاره پوش در واقع به طور مستقل از تلسکوپش عمل میکنه دیگه، یعنی در واقع در یه مدار خودش قرار میگیره، در یه فاصله دور از تلسکوپ، و بعد این دوتا با وجود فاصله طولانی که دارن با هم دیگه در واقع همکاری میکنن. درسته؟
They work together. And technically speaking, they're in the same orbit, but just very separated. Yeah, they're separated very far by tens of thousands of kilometers. And that's because the Starshade, because of diffracted light around the edges, it has to have a very specific configuration.
So,
فقط این نکته که احتمال داره که مثلا برای ناسا این امکان وجود داره که در ماموریت‌های بعدی خودش در آینده در واقع استارشید رو اضافه بکنه به مثلا ماموریت Habitable Worlds Observatory، یا اینکه بعد دوباره از اول شروع کنن طراحی رو.
No, we could add it to that. As a telescope, the Habitable Worlds Observatory at this point is planned to be what we call Starshade ready.
Oh, okay, yes.
The telescope can operate with a Starshade. And you know what? Any space telescope could be made Starshade ready. So we're working with people around the globe so that if other countries want to launch a telescope, as long as it goes to the right orbit, we're trying to encourage people to make things Starshade ready so we have some opportunity to launch it sooner than Habitable Worlds Observatory, because Habitable Worlds Observatory won't be launching for a few decades.
Yes.
و از نظر تئوری حداقل احتمال وجود داره که ما بتونیم چند تا ستاره پوش رو در فضا قرار بدیم برای ماموریت‌های مختلف؟
Sure, we could have multiple Starshade observatories. We could have multiple Starshades with the same telescope. There's a lot of options.
و فکر کنم که تایملاین خوشبینانه‌مون برای این ماموریت چیزی حدود میانه دهه 2030 تا میانه دهه 2040 باشه، درسته؟
Mid-2040s is what
mid-2040.
Habitable World Observatory is mid-2040s, yes.
Before that,
و قبل از اون ما تلسکوپ نانسی گریشرومن رو داریم. پروژه‌های دیگه‌ای هم هستش، چه در رابطه با فضا، در واقع رصدخونه‌های فضایی، چه در رابطه با رصدخونه‌های زمینی که برای بررسی پرخورشیدی‌ها در حال اجرا باشه.
Yes. And remember, we just briefly touched on that each telescope has its own category of.
Yes.
We talked about James Webb, that does the Earth-sized planets around the M-dwarf stars. The Starshade would handle Earth 2.0 around sun-like stars. There is another category, and that is the large ground-based telescopes.
Yes.
Such as the European Extremely Large Telescope called EELT. That telescope, if you Google up about it, you will see the dome like built already and moving.
Yes.
And this is a very large telescope. Its aperture, like the diameter of the telescope, is 39 meters. It's made of a lot of little mirrors working together. It's very big because our largest ground-based telescopes now that work at optical or near IR, they are 10 meters.
10 meters.
Yes, we're scaling up by a factor of 4. And these telescopes, you know what they'll be able to study? Our very nearest star, Proxima Centauri, has an Earth-mass planet. And they will be able to try to image that planet, directly image. They don't need to block out the light to 1 part in 10 billion. It's more like 1 part in 10 million. And they think they can do it. And they think that they're able to study that planet in the near infrared in its own reflected light. So that'll be a big breakthrough. And that's our first chance to study a star, and our nearest star and its planet.
Wow. And
پس هنوز عصر رصدهای زمینی در این حوزه به اتمام نرسیده. ما هنوز کلی ابزار داریم که میتونیم برای این منظور به کار ببریم.
We do, and I think it's like, I'm sure other areas in astronomy that you're familiar with, that it's very observationally driven. And so every time we get a new telescope, we'll be more and more surprised.
و هر زبانی هم که در واقع ما ابزارمون بزرگتر شده، جهشی در ابزار داشتیم، تاثیر مهمی در درک ما داشته. در رابطه با جستجوی حیات، شما به طور خاص بر روی اون چیزی که به نام بایوسیگنیچرها معروف هستن، اثر انگشت زیستی فعالیت میکنید. در واقع ترکیبات شیمیایی که در جو یا سطح سیارات فراخورشیدی میتونن وجود داشته باشن و شاید نشون دهنده وجود حیات در اون سیاره باشن. توی سالهای اخیر موضوع دیگری هم مطرح شده که ازش به عنوان تکنوسیگنیچر یا نشانه ها و اثر انگشت فناوری نامیده میشه که برای جستجوی حیات به کار میره. بعضی وقتا به نظر میرسه که این ایده هنوز تو قلمرو علمی تخیلی قرار داشته باشه و ما هنوز واقعا به اونجا نرسیده باشیم. فکر میکنید واقعا صحبت در رابطه با تکنوسیگنیچرها الان موضوع جدی هستش یا اینکه موضوعی که باید چشمی بهش داشته باشیم ولی الان تمرکز علمی نیست؟
Right. Well, I have decided I love technosignatures, gases anyway, because with our search for signs of life by way of biosignature gases, we've run into a problem actually. And this problem is more philosophical or societal, and that is that we're trying to find a gas that doesn't belong. Like on Earth, we have oxygen made by plants and photosynthetic bacteria. And oxygen is so reactive, it shouldn't be in our atmosphere unless it's continually produced. And therefore, the argument is strong that a planet with oxygen will have life. But what has happened since we've last spoken is for every gas we can claim exists, made by bacteria or plants or something, another team will find ways to make it without life.
Exactly.
And there's no exception yet.
Yes.
در واقع منظور اینه که فرآیندهایی وجود داره که نتیجه اون ممکنه اون چیزی باشه که ما به عنوان بای پروداکت حیات میشناسیم اما دلیل دیگه ای داره که به وجود میاد.
Maybe, and people are kind of fighting over this. Like some physicists, geochemists will say, we always have more iron than oxygen on a planet, so it's unlikely that you could build up oxygen without life because any iron would react away and destroy it. And if the planet has like plate tectonics and volcanoes, it should really anyway, people are kind of arguing about it, but if you imagine a technosignature gas, a very complicated gas that life never touches, one thought process, you see where this is going, is that, if it can't be made by abiotically, like if you get a molecule so complicated or so obscure that we can't find a way to make it in our models or with chemistry without life, it might give you a bit of a more robust certainty that life is making it. Does that make sense? So there's a favor for technology that comes out of this thought that, hey, you know what? Nature, like bacteria, has the same molecules to work with that geochemistry does. Life can make a reaction happen somewhere else on the planet. Volcanoes might make it, or another process, photochemistry. But if you have a truly complex molecule, it's thought that only life can make it. And so technosignatures are born out of that concept. Does that make sense to you?
Yes, exactly.
و به عنوان حالا یه آزمایش ذهنی اگه بخوایم انجام بدیم، اگر بخوایم این روش جستجو رو برای تکنوسیگنیچرها روی زمین اعمال کنیم، فرض کنیم که ما موجودات بیگانه‌ای هستیم، فرازمینی هستیم که دنبال حیات داره میگرده، وقتی که دنبال این تکنوسیگنیچرها میگردیم چه چیزی رو دنبالش باید بگردیم یا چه چیزی رو اونا ممکنه روی زمین ببینن؟
Right. Well, the ones people love to talk about are chlorofluorocarbons.
Mhm.
And we might not be producing those forever because they're bad for our atmosphere.
Yes.
But at least for now, we've produced a whole bunch of them. But these aliens, they wouldn't be able to detect it with any of the telescopes we're planning to build. Like even Habitable Worlds Observatory wouldn't see it. They need to have a more sophisticated telescope in the future.
Yes.
But perhaps they're thousands of years ahead of us. That's not that much in the scope of
Yes.
things. And perhaps they already found oxygen and water, and they're fighting over whether that oxygen is a biosignature. And maybe then they're motivated to build their next generation telescope to search for technosignature gases like chlorofluorocarbons. So it's possible.
پس شاید ما در حال یه رقابتی با موجودات فرازمینی هستیم ببینیم کی اول میتونه این تکنوسیگنیچر رو شناسایی کنه.
And
Maybe, but I want to mention one more thing to you, which has been so insanely crazy. But, people have found planets, at least one planet orbiting a white dwarf star.
yes.
And they found it from TESS, the TESS mission.
Yes.
And they've studied the atmosphere at the James Webb Space Telescope. It's a giant planet. But people are trying to see if there could be Earth-sized planets transiting white dwarf stars. And the Earth and white dwarf are about the same size.
Oh.
And so, yes, looking at if we can find other Earths around a white dwarf and study their atmospheres by transmission spectroscopy as the planet goes in front of the white dwarf and the white dwarf finds through the atmosphere, then we can plausibly detect chlorofluorocarbons because the signals, the ratios of the planet and star are much more favorable than what we currently have with planets and M-dwarf stars.
پس یه بار دیگه ممکنه نخستین نشانه ها از حیات از جایی کاملا غیر منتظره مثل یه سیاره بیادش که داره به دور یه کوتوله سفید میگرده و اونجا پیداش کنیم.
Maybe, but let's unpack this a little more. Like our sun in the future, when it finishes producing hydrogen and helium, it'll no longer be able to sustain itself as a star. And eventually it'll expand, it'll engulf Earth. So our Earth will be gone.
Yes.
It'll expand and kill things. And eventually the outer layers will float away. And they'll be left with a white dwarf, a tiny, very, very dense, like a glowing ember.
Yeah.
But other things in our system, like Jupiter and Saturn, and maybe Uranus, Neptune, maybe some other objects will, because of the conservation of angular momentum, they will now be orbiting closer. In fact, people don't even understand how these planets survived or why they're there or if they had to form from scratch. But it's kind of hard to understand where these planets came from and why they're there at all. But the reality is that people are now on the hunt for them. They're using the TESS space mission to search for these transiting Earths around white dwarfs if they exist, and they hope to study their atmospheres, and that might be our first chance.
Wow.
من میخوام یه سوالی ازتون بپرسم که احتمالاً نباید تو برنامه زنده چیزی که آدم سریع به ذهنش میرسه بپرسه، ولی به هر حال ممکنه که در این سناریویی که گفته میشه و درباره این سیاره‌ها، اون سیاراتی که به نام ساب-نپتونین ها میشناختیم نقش بازی کرده باشن، اینا در فاصله دورتری بودن، ساختار گازی داشتن، زمانی که ستاره به مرحله غولی خودش میرسه تشعشعاتی که داره باعث میشه که گاز اونها دور بشه، مواد سبکتر و مواد سنگین‌تر چیزی شبیه یک سیاره سنگی یا زمین مانند رو تشکیل بدن.
Planets?
Yes, I really like that idea. That's a great idea. It's definitely possible that they lose their atmosphere, then they get sucked in.
Yeah.
Could be.
There was
انقدر در رابطه با این موضوع سوالات هیجان انگیزی وجود داره، من هر بار بهشون فکر میکنم نمیتونم جلو هیجان زده شدن خودم رو بگیرم. اما زمانی که راجع به توان بالقوه کشف حیات صحبت میکنیم، حتی داخل منظومه شمسی خودمون ما دنبال این نشانگان میگردیم، دنبال نشانه های زیستی که ممکنه وجود داشته. به نظر مثلا نزدیکتر داریم میشیم که اونها رو شناسایی کنیم، اگرچه که برخی از اینها ممکنه که خیلی قابل اعتماد نباشن، اما برخی از اونها به نظر میرسه که دارن از یه جاهای غیر منتظره میان. برای مثال اخیراً شما مقاله منتشر کردید در رابطه با میزان پایداری آمینو اسیدها در فضایی مثل جو سیاره زهره که به طور سنتی زهره آخرین جایی هستش که تو منظومه شمسی ما بخوایم دنبال حیات بگردیم. واقعا فکر میکنید که ممکنه که چنین جایی مثل جو زهره در منظومه شمسی میزبان نوعی حیات باشه و زندگی بتونه شکل بگیره؟ حالا به خصوص با توجه به دیتاهایی که ماموریت‌های مثل داوینچی و وریتاس در واقع قراره که پرووایید کنن به ما در اختیارمون بذارن، چقدر چنین چیزی ممکنه و چقدر دیوانه کننده است که ما بتونیم حیات رو اینجا پیدا کنیم؟
And how crazy it is.
It's crazy, yeah. I do love to say in exoplanets and the search for life, the line between mainstream and crazy is constantly shifting.
Oh, yeah.
Because as you pointed out in the beginning of the conversation, it was crazy 30 years ago to work on exoplanets. People thought they weren't real. Then they thought the field would dead end because it's so hard to find them. People thought we only had solar system planets, but instead we have this vast number of easier to find planets.
من خاطرم است که در خاطرات شما میخوندم که حتی خیلی از مشاوران اساتید شما میگفتن که چرا دارید دنبال این حوزه میرید.
Right, exactly. And so, but you know, younger people sometimes you don't have any logic. You just go and do things.
Yeah. You know what I mean? Yeah, exactly.
So I didn't have to really worry about money or getting a job because I thought I was, you know, when you study physics and even astronomy in grad school, you're not necessarily expecting to become an astronomer, although that's your desire. You know that we're told in North America that you'll be trained to get a job. You can work in data science or work in industry. So I didn't have that concern. Like the professors had a concern. They were already a professor. They need to get money. They have to have a grant for something reasonable. Yes. But as a young person, like I didn't worry about that. So the thing with Venus is it is definitely crazy to search for life. The surface of Venus is so hot due to the massive carbon dioxide greenhouse atmosphere. We're all taught as children that it's no life can survive there. You know, we humans would just melt. We'd fall apart on the surface. But just like on Earth, if you climb a mountain or go in an airplane, it gets colder and colder. Yes. And that's also true on Venus. So the idea is that in the clouds of Venus, high up, 50 kilometers above the surface, it's the right temperature for life. And you know, over half a century ago, Carl Sagan put this idea out there.
Yes.
But we don't think he knew what the clouds were made of. They didn't know the clouds. They're not water like our Earth clouds. No, they're made of sulfuric acid. They're so toxic and dangerous. It kills all of our life. So that's why it's crazy, because you couldn't imagine life in a solvent that destroys us. If you put it, like, obviously you don't want to get sulfuric acid, but if you spilled it on your skin, it will burn a hole. It will kill the body. It's so bad. So it's crazy to think of life there. But so Da Vinci is going to go into the atmosphere. Another NASA mission, Veritas, and a European Space Agency mission, Envision, they will go to Venus in orbit. Mm-hmm. But none of them are going to search for life because it's too out there. They're not going to probe the cloud particles or anything. So I've taken it upon myself to lead a group. We call ourselves Morning Star Missions to Venus.
Wow.
You know how Venus, it's visible. I think it's visible in the evening at this present time. But sometimes it's there in the morning if you wake up, right? So the Morning Star missions, a new dawn for space, a new hope to find life. So we have a series of missions we're planning to send to Venus. Our first mission is in partnership with Rocket Lab called the Rocket Lab Mission to Venus. That is targeted for launch next year. It won't find life, but it's the first in a series of private-public partnerships.
Sure.
So in related to these missions, that's me and an extended team, have been doing laboratory experiments. And this is where the amino acids come in, because we put our amino acids, our 20 biogenic amino acids, in concentrated sulfuric acid to see what would happen. Now, the thought would be that they would just be completely destroyed, but in fact, they survive.
Wow.
With one exception, and about half of them are chemically modified. So the sulfuric acid donates a component to them. But it's just pretty surprising, actually. And it's not just our amino acids, it's a whole lot of other molecules. Now, fair to say, a lot of molecules are destroyed in sulfuric acid, but we found enough of them that can survive that opens the possibility to sulfuric acid itself being a solvent, and that there's another kind of life, some primitive life, that's not using water, but it's using acid.
چنین جستجویی شاید منجر نشه که ما حیات رو روی زهره پیدا کنیم، اما چنین تحقیقاتی نشون میده که چقدر توانایی بالقوه حیات برای شکل‌گیری در عالم بی انتهاست و شاید در خیلی از محیط‌های غیر قابل تصور ما بتونیم که جستجوی حیات رو توسعه بدیم.
Like if we could establish that Venus is actually habitable, even if we don't find life there, but we show that complex biomolecules can survive in sulfuric acid, maybe not our biomolecules, but slightly on them. Yes, it definitely opens things up. Because you know how you've mentioned Earth 2.0? Well, what if we searched really hard and all we find are Venus 2.0? Like it might be.
Yeah.
So we're definitely with you. We're trying to expand the definition of what it means to be habitable using science and not just our own personal bias.
توی این فرآیند در واقع ما نه تنها داریم تحقیقات علمی رو توسعه میدیم در رابطه با حیات، بلکه شاید حتی معنای فلسفی دیدگاهی که راجع به زندگی و معنی اون رو هم داریم گسترش میدیم. اما زمانی که راجع به مکانهای غیرمنتظره داریم صحبت میکنیم، یکی از اونها اقمار سیارات منظومه شمسی و فراخورشیدی ها هستن. شما اشاره کردید که ما هنوز توانایی فنی برای بررسی اونها رو نداریم. اخیراً علاقه بیشتری برای بررسی اقمار منظومه شمسی مثل یوروپا، انسلادوس، تایتان و بقیه ایجاد شده و ما از نظر سوال من اینه که آیا از لحاظ تئوری شروع کردیم به بررسی امکان وجود حیات در چنین جاهایی یا شناسایی اونها، اگرچه از نظر فنی محدودیت داریم، یا اینکه حتی کار بر روی بخش تئوری اون هنوز آغاز نشده و راجع به اقمار باید صبر کنیم تا آینده.
Well, in terms of satellites as moons of exoplanets, I just want you to know that on our wish list, like imagine astronomers have their wish list, it's probably the one thing we haven't found yet. Like, we're hoping that we would find lots and lots of moons. So we're still not even at the point where we found them. So there's not too much work going on theoretically about them. But there could be, but we're just in a great place in exoplanets where we're too busy detecting things now to worry about, to like fixate too much on theory.
و حتی مثلا با پروژه‌ای مثل استارشید احتمال داره که بتونیم اقمار بزرگی از فراخورشیدی ها رو در دهه‌های آینده پیدا کنیم یا نه؟
Well, Starshade won't help with moons, but transits might. People are working to see, if we can find them sooner. So hopefully we'll be able to talk about moons soon.
Sure. And
شما یکی از پیشگامان این رشته هستید و از آغاز عصر طلایی فراخورشیدی ها درگیر اون بودید. چیزی که ذهن من رو در واقع تحریک میکنه که بپرسم این هستش که برای شما اون چیزی که به نوعی میشه گفتش که جام مقدس این رشته است، اون چیزی که واقعا چشم انتظارش هستید که کشف بشید، چی هستش؟ چه چیزی؟ میدونم سوال زیادی وجود داره، اما مهمترین چیزی که برای شما اهمیت داره که پیدا کنید کدوم هست؟
Sure. Well, I think that we've touched upon the Holy Grail, in my mind, is to find the Earth 2.0. Find another Earth around a sun-like star, one with oceans and continents and thin atmospheres, a place that reminds us of home. To me, that's the number one Holy Grail, and that's what I work hard to make sure it can happen somehow in our future. But a closer one is just finding a sign of life, any sign, even if not everyone can believe it.
Yes.
I think that's kind of where people are really pushing the boundaries of. As we talked about before, it may be hard to believe because there's always other options of non-life, but just finding the gas, making that all real is really a big push.
That's fantastic.
با توجه به اینکه وقت من داره تماشا مثلا دو سوال آخر رو بپرسم، بدیهیه که برای جستجوی فراخورشیدی ها ما احتیاج داریم که تکنولوژی فوق العاده پیشرفته داشته باشیم، نیازمند تلسکوپ های فضایی یا تلسکوپ های بزرگ زمینی هستیم و کلا فناوری پیشرفته نیاز داریم. سوال من این هستش که علیرغم این موضوع و با توجه به پیشرفت‌هایی که الان برای مثال در حوزه‌ای مثل هوش مصنوعی به وجود اومده، آیا فکر می‌کنید که هنوز جایی برای فعالیت منجمان آماتور وجود داشته باشه که بتونن کمکی رو به جامعه علمی انجام بدن در جستجوهای خودشون و برای کمک به اونها برای عمیق کردن تحقیقات در این زمینه، حالا در زمینه‌های مختلف، برای مثال چه در رابطه با داده کاوی ها یا اینکه کمک به رصد یا هر جور کمک دیگه‌ای که از دستشون بر بیاد که بتونن که نسل آینده این تحقیقات رو پیش ببرن.
Well, the crowdsourcing for enthusiasts has been very helpful in the past. All the Kepler data, all the test data made it to planethunters.org, where individuals looked at all the data by eye. And that was amazing because it's kind of the opposite of what you said, like AI. Looking at everyone is the opposite. But it really is important because our computer, our brain remains the best computer in the end in terms of recognition. So it would be wonderful if the microlensing folks can put all their data bit by bit onto a similar way for people to look through. That could be really helpful. As far as observers go, you have to have a pretty sophisticated setup. But people have been very helpful for, sometimes there's a long period transit. Like I remember one, it lasted for 11 hours or something crazy. And people were called upon all across the globe to get ready to observe their piece of it. In the past, observers in a special part of the world, like New Zealand area, were really helpful for microlensing, because microlensing events also can last more than half a day. And the problem is, if you can't, there weren't professional telescopes like in that one longitude.
Yeah, exactly.
Needed to help. So there are a variety of ways people can help out in the future.
That's good.
سال آخر من در واقع در مورد مخاطبانمون هست، به خصوص جمع زیادی از مخاطبان ما رو افراد جوانی تشکیل میدن که دارن مسیر شغلی خودشون رو بررسی میکنن و شاید بر خاطر این گفتگوی ما در واقع جرقه علاقه به بررسی و ادامه تحقیقاتشون در این رشته برانگیخته شده باشه. اگر کسی بخواد وارد این رشته بشه امروز، حالا چه به شکل آکادمیک چه به صورت در واقع خودآموزی، توصیه شما چی هستش؟ به نظرتون چه چیزهایی رو باید یاد بگیره و به طور خاص چه مهارتی هست که ضروریه که در اون به برتری برسه برای که بتونه این رشته رو ادامه بده؟
I would say the number one skill right now is computer programming of some kind. You don't have to be a professional level programmer, but understanding programs and how to use them is really, really important. Today, with all the data we have, data science, so studying, it doesn't have to be a course of study, but having a project in it or taking one course in data science will be extremely helpful. Just how to manage large data sets. Everyone in every field of science wants to use AI, so that is useful as well. But I think it's the fundamentals. It's computer programming, it's math, it's physics. For a young person still in school, those are the skills you want to build. And they're also very helpful because of what we said earlier, is that not everyone will end up being an astronomer. So you want to make sure you're also learning skills so you can get a job and support yourself at the end of the day.
دکتر سیگر خیلی ممنون از وقتی که در اختیار گذاشتین. همیشه صحبت با شما الهام بخش و لذت بخش بوده. اگر نکته پایانی هست که مایلید بگید، من میدونم خیلی چیزا رو جا انداختم، ولی اگه نکته پایانی هست که دوست دارین با مخاطبانمون در میون بذارین، وقت در اختیار شماست.
Well, I do have two things. One is for the younger people out there, is to try to find something that you love doing, that you're also good at, and that leads to a job. And not all things in high school and in university are one-to-one corresponding to a career. So try to be patient and sort through what's out there. My final thought to everybody is the next time you go outside, even if you live in a city, and you look up at the stars, you can wonder what kind of planet orbits that star.
امیدوارم این گفتگو علاقه شما به دنیای شگفت‌انگیز علم و به طور خاص دنیای شگفت‌انگیز و سیاره‌های فراخورشیدی رو برانگیخته باشه و زمانی که به آسمون نگاه بکنیم یه یادآوری باشه برای اینکه این آسمان شبی که می‌بینیم و در واقع آسمان پرستاره‌ای که می‌بینیم مملو از جهان‌های شناخته و ناشناخته‌ای که هر کدوم در واقع یک دنیای شگفت‌انگیز رو تشکیل میدن. در بخش توضیحات این ویدیو شما میتونید فهرستی از کتاب‌ها و منابع مختلف رو که اگر علاقه‌مند به این موضوع شدید شاید کمکتون کنه که اطلاعات بیشتری به دست بیارید پیدا بکنید. و مطابق معمول تا شب دیگه از این در این شب‌ها لطفا مراقب خودتون باشید و خدا نگهدار.